with logarithms, we've already looked at common logs, which is base 10. When we see a log and it doesn't list a base, that base is base 10. We have another log that is used very frequently. It's called natural log. Natural log is used with the base of e, that irrational number that we've started working with exponential growth and decay problems. It comes into logarithms, and it's actually a base that is used very frequently and is represented on the calculator as well. So when we see when we see a problem that lists an L and an N, that's log base e of x. That problem we can actually do the log where it's base e. Now the L and the N represent the words natural log. We just have an L for the log and N for the natural. Natural log is log base e. On our calculator, you'll look over on the left side and you'll see an LN on your calculator. So when you see that, that is base e for the logarithm. So take a look here. It's right over here, ln, right underneath the log key. That's when we're going to use it in conjunction with exponentials that have e as the base. All right, so let's go ahead and talk through how we can convert and use these. So for instance, if we had this exponential with e, the irrational number cubed is equal to x, what we can do is we can convert that by doing the circle tour by saying if we're going to do log base e of x is equal to 3 when we convert it into a log. Now log base e we're going to list as natural log of x, and that's equal to 3. So notice this one doesn't have a base either. It's represented with the ln. When we see that, we've got to immediately think of natural log. So that's our answer, converting that into a natural log. Just let's look at this and using a calculator to do this calculation. 6 plus a natural log of 8. So let's go ahead and do that on our calculator just to see. So 6 plus the natural log, so ln of 8. And when we do that, we get an answer of 8.08 or 8.07, etc. So we can use that calculator key to get some answers pretty quickly with this natural log. If we take the 6 off, it means natural log of 8 would be 2.08 approximately. All right, so let's go ahead and do a couple more problems. Let's solve some equations by converting. So we're gonna, this problem is just a review of solving by converting to an exponential. Why we're gonna do that is just to remind us of that process, and then we can do that with natural log problems as well. So if we have any base here, log base 4 in this case equal to 2, this means we're gonna set up the exponential, so the answer to a log is the exponent. So we're gonna have 4 to the second is equal to the inside 2x minus 3. And we're going to solve that. That's 16 equals 2x minus 3. Add 3 to both sides, you get 2x equal to 19. Divide by 2, you get x equal to 19 halves, which is 9.5. So 9.5 is our answer. We do have to check our answers when it's a logarithm to make sure that we're not taking the log of 0 or a negative. We put in 9.5 here. 2 times 9.5 is equal to 19. 19 minus 3 is equal to 16. Log base 4 of 16, 4 to the second is equal to 16, so it works. Okay, but we're just making sure that we don't get 0 or a negative in there. All right, let's take this exponential and convert it into a log and see if that can help us in finding what the x is. I'm first going to get the e to the x by itself by dividing both sides by 3. So get rid of the coefficient in front, divide both sides by 3. And now we're going to do log base e of 10 is equal to x. Now, when we do this, notice that we can do this on our calculator because this is just the natural log of 10 is equal to x. We actually have a calculator key that allows us to do that. We're going to do natural log of 10 on our calculator. That gives us a value of about 2.30 and goes on, so we'll round it to 2.3. So our answer for x is approximately 2.3. So there's our answer for it. So the main idea here is that when we deal with natural logs, that's when we have a base of e. The shorthand for listing that is ln of x rather than log base e of x. It's easier to write, it's used very frequently, it's found on our calculator where it's actually a calculator key. So as we do more and more problems with e and logs, we're going to start looking at natural log as part of that.